Hello everyone, I'm Matt. Today I'm going to talk about live notes. Let me start off with this. Have you ever been in a presentation, lecture, or meeting where the speaker is engaging but there are no visual aids? It can be hard to follow along, especially with complex topics where key points often get lost. Today we want to introduce live notes, a tool designed to solve exactly this problem by transforming spoken words into real-time visual summaries. Now, here's the problem. Many speakers, whether they're teachers, conference presenters, or even leading a team meeting, sometimes speak without prepared slides. Maybe they didn't have time, or the format is more conversational. While live transcription tools exist, they often struggle with accuracy or provide just a wall of text, making it hard to grasp the main ideas. The core issue is that valuable insights shared verbally can easily be missed or forgotten by the audience without some form of visual reinforcement. Now, let's see it in action. It's actually running right now, summarizing as I speak. My talk right now will demo the project and be a presentation about the project. Pretty cool, right? Our solution uses a combination of advanced speech-to-text technology to capture what's being said, and then leverages AI summarization to instantly identify and extract the most important points. The beauty of this is that it requires zero slide preparation from me as the speaker. Now, the interesting part. How does it work? As I talk, my voice is captured. In this case, the computer is recording the audio continuously. This audio is transcribed into text in near real time. Then, the crucial part happens in our backend. An AI agent analyzes the incoming text, and then it intelligently decides when there's a complete thought or enough context to process. Once it decides, the text chunk is passed to our summarization model. This uses an LLM to extract the core ideas, structure them with headings and bullet points, like the ones you're seeing generated right now. Finally, these structured notes are instantly sent via a WebSocket to a client display, like I'm showing here. This way, you can have one computer doing the processing and another computer on the same network connected to the screen. Notice how, as the topic shifts, the system can create new headings or add relevant points under the current one. It's constantly adapting to the flow of the speech. The client display isn't just static either, as I can interact with it. The plus and minus keys on the keyboard can adjust the text size according to my preference. And if I'm moving too fast or someone wants to review a previous point, we have the left and right arrow keys to navigate between the main topic headings. This pauses the automatic scrolling. When you want to catch up to the live summaries again, I just have to press enter and it will snap back to the bottom. This interaction allows you to show your AI-generated summary at your own pace while still benefiting from the live summary. As you've seen, this makes presentations much easier to follow. The main benefits are significantly improved audience engagement, better information retention, and the complete removal of slide preparation time from the speaker. So that's Live Notes in action, demonstrating itself throughout this talk. It's a tool designed to bridge the gap between spoken word and visual understanding, making live communication more effective and accessible. We're still working on the app, refining and adding more features, and we're hoping to use it in a much bigger setting with a larger audience. We welcome your feedback. Thank you for your time and attention. Before you go, I'll leave you with another demo, this time using speech from a recent keynote talk by NVIDIA.
And so the second question is, how do you train the model? And the third is, how do you scale? How do you find an algorithm whereby the more resource you provide, whatever the resource is, the smarter the AI becomes? The scaling law. Well, this last year, this is where almost the entire world got it wrong. The computation requirement, the scaling law of AI is more resilient and, in fact, hyper-accelerated. The amount of computation we need at this point as a result of agentic AI, as a result of reasoning, is easily 100 times more than we thought we needed this time last year. And let's reason about why that's true. The first part is, let's just go from what the AI can do. Let me work backwards. Agentic AI, as I mentioned, at this foundation is reasoning. We now have AIs that can reason, which is fundamentally about breaking a problem down step by step. Maybe it approaches a problem in a few different ways and selects the best answer. Maybe it solves the same problem in a variety of ways and ensure it has the same answer, consistency checking. Or maybe after it's done deriving the answer, it plugs it back into the equation, maybe a quadratic equation, to confirm that, in fact, that's the right answer, instead of just one shot blurbing it out. Remember, 2 years ago, when we started working with ChatGPT, a miracle as it was, many complicated questions and many simple questions, it simply can't get right, and it's understandably so. It took a one-shot, whatever it learned by studying pre-trained data, whatever it saw from other experiences, pre-trained data, it does a one-shot, blurps it out, like a savant. Now, we have AIs that can reason step by step by step, using a technology called chain of thought, best of n, consistency checking, a variety of different path planning, a variety of different techniques. We now have AIs that can reason, break a problem down, reason, step by step by step. Well, you could imagine, as a result, the number of tokens we generate, and the fundamental technology of AI is still the same. Generate the next token, predict the next token. It's just that the next token now makes up step one. Then the next token after that, after it generates step one, that step one has gone into the input of the AI again as it generates step two, and step three, and step four. So instead of just generating one token or one word after next, it generates a sequence of words that represents a step of reasoning. The amount of tokens that's generated as a result is substantially higher, and I'll show you in a second. Easily 100 times more. Now,